Hello students, welcome to Lucky Learning. Here in this video, I am going to discuss what are the characteristics of a multiprocessor system. First, we will understand what is multiprocessor. A multiprocessor system is an interconnection of two or more processors, or we can call two or more CPUs with memory and input-output equipments. The term processor in multiprocessor can mean either a central processing unit or an input output processor. It means it may have two CPUs, one IOP, or two CPUs, two IOPs. Like if it has more than one processor, it's called multiprocessor system. And these multiprocessors are classified as multiple instruction stream, multiple data stream computer. This is called MIMD computers that we have discussed in the Flint's classification of computers. The similarity and distinction between a multiprocessor and multi-computer systems are both support concurrent operations, means simultaneous operations are allowed by both multiprocessor and multi-computer. But the difference is in a multi-computer system, it is a network consists of several autonomous computers that may or may not communicate with each other. It is a network of computers and that computers may communicate or may not communicate over the network. When in the case of multiprocessor system is controlled by one operating system, it is controlled by only one operating system that provides interaction between the processors and all the components of the system that cooperate in the solution of a problem. It means in multiprocessor system, one operating system provides an interaction between the processors to provide a solution for a problem. And multiprocessing improves reliability of the system. And the benefit derived from multiprocessor organization is improved system performance by multiple independent jobs can be made to operate in parallel, or else a single job can be partitioned into multiple parallel tasks, and that each partition can be executed in a different processor unit. The multiprocessing can improve performance by decomposing a program or a process into subprograms, or that all subprograms can be executed parallelly. A multiprocessor are classified by the way their memory is organized. A multiprocessor system with common shared memory is classified as shared memory or tightly coupled multiprocessor system. And this tightly coupled multiprocessor system tolerate high degree of interaction between the tasks. So means the programs that are executing concurrently that has high degree of interaction. And second thing is each processor element with its own private local memory. And when it comes to the tightly coupled, we have a shared memory. In the case of second one, loosely coupled system, we have each processor has its own private local memory. That is classified as distributed memory, or we call loosely coupled system. And if it is loosely coupled system, each processor has its own local memory so that interaction between the tasks is minimal. When in the case of tightly coupled system, interaction between the processes or programs are high. High degree of interaction is there in the case of tightly coupled multiprocessor system, and interaction is very less in loosely coupled system, because in loosely coupled system each processor has its own private local memory. In tightly coupled system, each processor, all the processors will have shared common memory. Here a few differences for the tightly coupled system and loosely coupled system. In a tightly coupled system, tasks or processors communicate in a highly synchronized fashion and communicates through a common shared memory, and shared memory system is employed in the computer. When in the case of loosely coupled system, tasks and our process do not communicate in a synchronized fashion. And this communication is possible by message passing packets. Means if one processor want to communicate with another processor, it is going to send some messages by means of packets. This is having overhead of data exchange, and it is called distributed memory system because each processor has its own private local memory. This is a block diagram of tightly coupled system and loosely coupled system. In a tightly coupled system, there are multiple processor units, and all the processor units uses shared memory modules. When in the case of loosely coupled system, each processor has its own local memory, and all these are communicated through a network. These are the block diagrams of tightly coupled system and loosely coupled system. And here computers can have different ways of organizing the memories. So far we have discussed shared memory and distributed memory. Along with that, I'm going to discuss about uniform memory and non-uniform memory. When in the case of shared memory, a global memory space accessible by all processors. Processors may also have some local memory. In the case of distributed memory, each processor have separate memory unit we call private local memory associated with each processor. And to retrieve information from another processor, one processor has to communicate with another processor by sending a messages. When in the case of uniform memory, all processors take the same time to reach all memory locations. In the case of non-uniform memory, memory access is not uniform for all processors. Means each processor will take some different times to reach different locations of the memory. We have understood what is multiprocessors and what are the classification of multiprocessors, and we have seen difference between multiprocessor and multi-computer, and we have discussed about loosely coupled systems and tightly coupled systems and their block diagrams and the differences between the different types of memories. Hope you have understood. If you like the video, please do like, share and subscribe. Thank you.